Good morning students. The topic is CPU scheduling algorithm. See, CPU scheduling algorithm is one of a very important concept in this unit because where in examination purpose where they'll be asking for 15 marks. So where the problem will be given and they'll be asking you to calculate, they'll be asking you to find average waiting time, turnaround time, response time, where how to calculate etc. things I'll be explaining today. Okay, so now see CPU scheduling algorithm. So once we talk about this scheduling, I have already told what is a scheduling. See, scheduling in a simple words you can understand it is like a plan or like how exactly a schedule can be done, so that each process which want to undergo execution, each process which want to execute, it will be getting equal chance. Okay, it is not like only few process will get a chance of execution and remaining process will not get a chance of execution. It is not like that. All the process will get equal chance of execution. All the process will get equal chance of using CPU. That is the way how a schedule will be working. Okay. See, like this CPU scheduling algorithm contains types. You have some number of algorithms under this. So in that very first one you have first come first serve scheduling algorithm. So once we talk about this FCFS, shortly call it as what FCFS. So it is nothing but, see, the name itself it is telling it is first come first serve. So whichever process comes first, that process will be getting a first chance of entering into a CPU, or that process will be getting a first chance of execution. Okay. Now see, in this you can understand, see, like a ready queue is there, CPU is there. I have already told you in the previous classes what is a ready queue. See, ready queue, which is very similar to the queue which you have studied in a subject called as a data structure. Okay, so in this ready queue, whichever process, see here you can see an arrow mark. So P1, P2, P3 is there. Whichever process, very first P1 will go for execution, P2 will go for execution, after that P3 will go for execution. So this is a way how one after other each process will go for execution to the CPU. Okay, why it is like this? Because it comes under the name itself, it is telling what it is, first come first serve scheduling algorithm. Whichever process comes first, that process will be getting a first chance of execution. Okay, and where by using this first come first serve scheduling algorithm, like where you will be calculating these three things. These three things which is also called as what, some of the criteria of CPU scheduling algorithms. See, criteria, it means these all the things has to be satisfied under CPU scheduling algorithm. Like you have average waiting time, average turnaround time, average response time. So where how you will be calculating average waiting time, you have some like a very simple formulas. See, waiting time is equal to starting time minus arrival time. Average, and you also have turnaround time. Turnaround time is equal to finish time minus arrival time. And the last one you have average response time. Response time is equal to first response minus arrival time. Okay, so this is the three formulas where by using these three formulas you will be calculating average waiting time, average turnaround time, average response time. Okay, now let us see with an example. Now the example, see, in examination, the table will be given like this with the two columns, process and burst time. Always you have to remember the burst time will be in the unit of milliseconds. It will be there in a unit of milliseconds. Okay, and P1, P2, P3 and respective burst time is given. So like here you have three processes as per the example given. You have three number of processes P1, P2, P3, and another side you have burst time. What is a burst time? See, burst time is nothing but the time taken by a process. Example, see, P1 it is given as what, 20 milliseconds. It means P1 want execution time of 20 milliseconds and P2 required of 3 milliseconds, P3 required of 4 milliseconds. So what is a burst time now? The time taken by a process for its execution. That itself it is called as what, burst time, and it is also telling what, it will be there in a unit of milliseconds. Okay, so this will be a table like this. The table will be given in exam where they will be asking you to apply first come first serve scheduling algorithm and calculate average waiting time, average turnaround time and average response time. Okay, now with an example, see, like this is a given problem. As I told you, this is a given problem, like where this is a very first step. So this is the very first step of the program, like of the problem. It is given like where you have to write a Gantt chart. It means what? Gantt chart you have to write. It means, see, like where how many processes are there? 3 processes are there. P1, very first process start with the 0, because very first process, because as I told you, it is a first come first serve, and whichever process is coming first, that process will go for execution first. Okay, it means process 1 will start using a CPU first at the starting time of 0, and here it is 20. Why it is 20? Because the time taken or the time required for P1 is how many milliseconds? 20 milliseconds. So where P1 starting with 0 and P2 will finish with what? 20 milliseconds. P1 will finish with 20 milliseconds. P1 is starting with 0 and finishing with the 20 milliseconds. Why? Because in the table they have given us a 20 milliseconds as a burst time. Okay, next one you have P2. See P2, and what is the time required for P2? Only 3 milliseconds. Coming to here, see already P1 is done. P2 starting with the 20 milliseconds. Why it is 20 milliseconds? Because from 0 to 20 milliseconds, P1 has taken it. P1 has taken, and P2 will start from 20. It is nothing but 21 to 23. Okay, 21 to 23, like 3 milliseconds will be taken by P2. So here you should not directly write 3. Okay, even though P2 want only 3 milliseconds, you should not write directly 3, because you will be taking what? Cumulative. It is nothing but after 20 plus 3, how much you will get? 23. Okay, 20 plus 3 you will be getting 23. And last one you have P3 process. Again P3 is starting with 23. Okay, and what is the time required? What is the burst time of P3? It is 4 milliseconds. So when we talk about 4, like 23 plus 4. See 23 plus 4 how much? 27. So this is the way how you write a Gantt chart, okay, which is very important. Once you write a Gantt chart properly, all the calculations you can do perfectly. Okay, now let us work with the calculation. Now very first, the Gantt chart is very clear now. Okay, like where you will be writing very first P1 with the milliseconds of 20 milliseconds, 0 to 20 will be taken by P1, and after 20 plus 3 will be taken by P2, after 23 plus 4 will be taken by P3. Okay, so this is the way how the Gantt chart will be written. Now let us calculate what is average waiting time, average turnaround time, and average response time. Okay, now very first one, average waiting time, and the formula is given here. Yes, and the formula is given, waiting time is equal to starting time minus arrival time. Now for P1, see P1, like as you all know, see I'll be writing shortly starting time minus arrival time. See shortly I am writing ST minus AT is nothing but starting time minus arrival time. So now P1. So for P1, see by using this Gantt chart, you will be calculating all the average waiting time, average turnaround time, average response time. Fine. And see P1. So now, and again very importantly you have to remember, see what is arrival time. See here P1 starting with 0, P2 is starting with 20, P3 is starting with 23. But what is called as an arrival time? See always you have to remember arrival time will be 0. Why? Because see once a process arrived to a CPU, then only an execution starts. Is it not? Because of that always a process or always an arrival time will be 0. Always arrival time will be 0. Now for P1, whichever for process which is there on left side, that is called as starting time, and which is there on right side, that will be called it as what? Finish time. This is also very important thing you have to remember. See P1 starting with 0 and finish with the 20 milliseconds. For this, to calculate average waiting time, we want starting time minus arrival time, and I told you that arrival time is always 0. Okay, so P1 is equal to starting time is 0 and arrival time is also 0. So where you will be getting it as what? 0. And P2, what is the starting time? See I am using a formula. P2 starting time is 20 and arrival time is 0. You will be getting what? 20 minus 0, you will get 20. And P3, you have the starting time is 23 and arrival time is 0, you will be getting it as what? 23. So where for this you will be calculating average. So you will be calculating average here is equal to 0 plus 20 plus 23. See divided by 3. Why it is 3? Because how many processes given in a table? 3 processes given, because of that we were divided by 3. So here you will be getting 43 divided by 3, you will be getting 14.33 milliseconds. See 14.33 milliseconds. Okay, so this is the way how you will be calculating average waiting time. So where again I'll repeat, P1 is equal to C, average waiting time is equal to what is the formula? Starting time minus arrival time, and I told you that arrival time will be always 0 and starting time is nothing but for a process which will be there on the left side. That is called as a starting time. Okay, so this is the way how you calculate average waiting time. Now next one we'll see how to calculate with the average turnaround time. The second one, average turnaround time. And what is the formula? See, what is the formula for average turnaround time? Turnaround time is equal to finish time minus arrival time. So where shortly I'll be writing FT minus AT. It is nothing but finish time minus arrival time. Okay, again the same thing. For P1 you will be calculating. See P1. And as I told you that arrival time is always 0. See P1 is finishing at where? 20 milliseconds. Where finish time of P1 is what? 20 minus 0 you will get 20. And P2 is finishing with 23. 23 minus 0, 23. And P3 is finishing with 27. 27 minus 0, you will be getting 27. Okay. So where once you do this, 20 plus 23 plus 27. So once you calculate this, you will be getting aroundly 70. Okay, you will get 70 divided by 3. And I told you why it is 3. Because number of process given in a table is how many process? 3 process. So where you will be getting the average 23.33 milliseconds. So this is the answer for turnaround time. Average turnaround time by using a formula called as what? Finish time minus arrival time. Where you will be getting a average turnaround time is equal to 23.33 milliseconds. Okay, I hope you can understand. So this is the way how you calculate average turnaround time. And the last one, see, and the last one you have average response time and the formula. See, average response time, the formula is given. Response time is equal to first response minus arrival time. First response minus arrival time. So where first response minus arrival time. And as everybody know, always the arrival time will be 0. But here you have to understand what is first response. See, once we talk about a first response, see, here how many processes? 3 processes are waiting. Okay. So once the CPU become free, once the CPU is idle, immediately process 1 will start moving to a CPU. It means what? The process 1 got a chance of execution. Process 1 got a chance of entering to a CPU. That itself it is called as what? Like a first response. It means what? The process is getting a response from the CPU to enter. The process is getting a response for execution. Okay. So because of this, see, P1, like when a particular P1 started, like when a particular process called as the P1 got a first response at 0. Okay, see, starting time is, that is true, which comes on left side. There is no doubt on it. And here when we come to the first response, see, once the process got a first response, see, when all the processes are waiting, when it got a chance of execution, that itself it is called as what? First response. So because of this, 0. First response is also what? 0. P1 first response is 0 only, and as arrival time is 0, you will be getting it as what? 0. And P2, again same thing, the first response, when a P2 got a chance, when a P2 got first response at 20 milliseconds, because P1 finished and P2 got a first response. Again here also same thing, 20 minus 0, you will be getting 20. And P3 also same thing, P3 got a first response at 23 milliseconds. 23 minus 0, you will be getting 23. And to calculate this average response time, the same thing, 0 plus 20 plus 23 divided by 3. And where you will be getting 43 divided by 3, you will be getting around 14.33 milliseconds. So here one more thing you have to remember, what average waiting time you will get and what average response time you will get, it should be same. So once it is same, there only you can clarify that what answer you got is correct. Okay, so this is a way how first come first serve scheduling algorithm, which is one of the very first algorithm of CPU scheduling algorithm, will be calculated. So it means what you have to understand here, see, as per the process which is order or which is been arranged in a ready queue, in the same order it will go for a CPU for execution one after other, because it is first come first serve. Okay, and here where we will be calculating average waiting time, average response time, average turnaround time, okay, by using a respective formulas. Thank you.